Hello, this video is about our final type of transformations, which is dilations. And so a dilation is a transformation in which a figure is enlarged or reduced. So you can highlight these in your purple book. Make sure you're taking your notes there. Also important is that dilations create what we call similar figures. So we have already talked about the meaning of congruent with our other transformations, rotation, reflection, and translation. Because dilations change the size, we cannot call them congruent, we call them similar. Now, the scale factor is going to indicate how much the figure will enlarge or reduce. A scale factor we will use denote with the letter K. So if you see the letter K, that's saved for factor. And if K is greater than 1, for example, a number like 2, let me change my pen, 2 or 1.5 even, that is going to enlarge the figure, make it larger. If K is less than 1, like 1/2 or 0.25, then that is going to make our figure reduce, make it smaller, a reduction. So let's get right into an example. We have triangle ABC, which has vertices A, -5, 5, B, -5, 10, and C, 10, 0. And our scale factor is K, which is equal to 3. So that is our important information there. K is equal to 3. And so what we can do with our scale factor is we're actually going to multiply it by X and then multiply it by Y. So I could, in general, say that my coordinate rule, remember this is a coordinate rule, how the points change. My coordinate rule is Kx, Ky, where K, that number can change, and that does mean multiplication when I put two letters next to each other. So for this particular one, I'm going to use the rule 3x, 3y, because K is equal to 3. So I now do that to my numbers, so 3 times x, now all of my x's here are the first numbers, that is our x's, and then all of our y's are the second number. So that's going to be 3 times -5 and then 3 times +5. Resulting in a prime, which is -15 and +15. All right, for the next, I have -5 again, and I'll just actually keep it consistent, write 3 first times -5, and make sure those look distinctly different, and then 3 times 10, so B prime becomes -15, 30, and finally 10, 0, so that's going to be 3 times 10 and 0, 3 times 0. Making C prime 30, 0. All right, very good. And moving on to example 2. Graph triangle ABC with vertices A, -2, 0, B, 2, 4, and C, 4, negative 4. And its image after a dilation centered at 0, 0 with a scale factor of 1/2. So they used the words in this problem, scale factor. Now this time I have a graph so I can see that dilation in action. I'm first going to write down all 3 of my points in the table. All right, and our rule for example 2 is 1/2 x, 1/2 y. So I'm actually going to multiply all of these numbers by 1/2. Now, depending on my preference for multiplication, I can multiply as a fraction. 1/2 times -2, for instance, would be times 2 over 1. I want to make both of my fractions, or both of my numbers into fractions. From there, I multiply straight across. 1 times -2 is -2, and 2 times 1 is 2. Now I do a final division, simplifying here, and that becomes -1. -2 divided by 2 is -1. So when I do 1/2 times -2, I get -1, my A prime. Okay, I can also take that 1/2 and I can write it as a decimal, use decimal multiplication, use my calculator. So I have some different preferences here. If I would like to use the decimal version, 0.5 times, well, we'll get to the next one, because 0.5 times 0 actually comes out to 0. I'm just lacking a little space, so you can go ahead and write 1/2 times 0 there. Okay, I fit it in there now. Moving on, I'm going to do 1/2 times 2 and 1/2 times 4. So I'll do the 1/2 times 2 here with my 0.5. So if I multiply, I would do 2 times 5, 10. 2 times 0, 0 plus 1 is 1. I move that decimal over right here because there is 1 decimal in the numbers that I'm multiplying. So that is going to come out to 1. And then 4 times 1/2. And so I can do that any other way. 4 over 1 times 1/2. That's 4 over 2, which is 2. You can also always think of taking half of something, cutting these numbers in half. And so we may be able to do that in our head. Half of 4, well, we already did that answer. We know that that's going to result in 2. And then half of -4 is going to result in -2. So 2, -2. Okay, so let's go ahead and graph each of these. I will do my original in blue. So -2, 0 is A. 2, 4 is B. 4, -4 is C. Ooh, I'm on the wrong place for some of those. Whoopsies. Let me back up. So 2, 4. Okay, there we go. And 4, -4. And so knowing what I had introduced about the scale factor being greater than 1 or less than 1, I know that this image is going to reduce or get smaller because of that scale factor of 1/2. So let's see it. -1, 0, we'll put A prime there. 1, 2, we'll put B prime there, and 2, -2, we'll put C prime there. And so I have my reduced triangle A prime, B prime, C prime. And our final example, graph triangle FGH with vertices F, -4, -2, G, -2, 4, and H, -2, -2, and its image after a dilation centered at 0, 0 with a scale factor of -1/2, excuse me. So again, I'm going to have that reduction there, but notice I have that negative sign. So what is going to happen to my triangle with a negative? Let's see. I'm going to write my points in here. Okay, so my scale factor, I'm going to use that -1/2 x, -1/2 y. So again, I'm taking 1/2 of all of these numbers. And luckily, look, they are all even. They can be divided by 2 or cut in half. So I will do 1/2 of -4, which is going to come out to -2. And 1/2 of -2, oh, really lacking room here, but you get it, that's a -2, so that will be -2, -1. For G, 1/2 times -2, oh, excuse me, making more mistakes. Let me go back to this. So I should have had negatives here in my -1/2. And that's actually going to end up giving us some positive numbers there. A negative times a negative is positive. So my negative here, make sure I have that in, -1/2 times -2 is going to give me that +1. And then -1/2 times 4. So this time it's a negative times a positive, which will give us a -2. And then finally, -1/2 times -2 and -1/2 times -2. And that will result in -1, -1. Okay, so let's see what this looks like. -4, -2 puts F there. -2, +4 puts G there. -2, -2 puts H there. Alright, and now for my primes, I'm at +2, 1, so that's F prime. 1, -2 is G prime, and yep, G prime, and then -1, -1. Oh, and found another mistake, just making all kinds. For that last one, it should have been +1, +1. Okay, so that's here. So what we should notice is that our triangle, not only did it reduce, but the orientation was changed. So if you think about the change that happened to my points, I did multiply my x and y by 1/2, but I also changed the sign of my x and y. And so if we recall, changing the sign of x and y is a 180-degree rotation. So using a negative scale factor will rotate our image 180 degrees and change the size. So thank you for watching all of this video, and I will chat with you soon.